Greetings, math friends. I want to talk about the rate of change formula, average rate of change for a curve, for a function. But I want to motivate this with some of the background that we've picked up from Algebra 1. I have the slope-intercept form for a linear equation, graphs a straight line. The m value here is the slope, and we have a nice formula for that. If we know 2 points on this line, whatever this line graphs, we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1 is the slope. Essentially, we could plug this into here if we wanted to. Most people don't do that. Then when you get into like Algebra 2 and pre-calculus and things like that, we change this formula up a little bit and we start to talk about the average rate of change. Why do we call this average when we talk about this in Algebra 2 and not when we talk about it in Algebra 1? You may have heard slope called rate of change in Algebra 1, but not average, because this value is a constant when you're talking about a straight line. So we don't have to worry about the idea of average, because any 2 points that you choose on this line are going to have the same slope with the line connecting them. But when you move to something that has a curve to it, like a quadratic equation, which graphs a parabola, we now no longer have a straight line. Every point that we choose along the curve will essentially have a different slope at that point. That's why we have to start talking about the average rate of change, because when I choose 2 points on this, I can put a line through there, or I can come out here a little bit and I can put a line at like the midpoint on the curve, and I can put this tangent line out here. So we have a secant line and a tangent line that we could talk about. The average part of this is whatever line we find, whether it's the secant or the tangent, has a slope to that line, but it's not exactly the slope of the curve itself. So it is the slope on average on this interval between these 2 points that we've chosen. If I add an axis here, and I come down here, this will be my first x value, and I come down here, this will be my second x value. With this x value, I come over to the y-axis, right? And I'll have a y value, that'll be my y sub 1. And then over here, y sub 2. So now we have these x sub 1, y sub 1, x sub 2, y sub 2 that we have from this formula. But this isn't what we are given in Algebra 2. So let's make one more step away from Algebra 1 into the realm of Algebra 2. In Algebra 1, you are probably eventually introduced to function notation, where they say, take away this y value, and we are going to call this f of x. So everything's the same except this y is substituted for f of x. Well, that's exactly what we're going to do as we look at the rate of change formula. Instead of m, I'm going to put a capital R here, because now it's not exactly this, because this is a constant and this is an average over these points. And just like we replaced this y with f of x, each of these y's now have to be replaced with f of x. And notice that this x is the input into the function, and we have two x's, we have two x's. So if x sub 2 is the first x value that I'm plugging into the function, then this is going to be f of x sub 2, the x value that I plug in. X sub 2, y sub 2. The y is replaced by the f of x. And then we do that x sub 1, f of x sub 1. So there is our average rate of change formula. We need one more piece to this, though. We have to know what interval we're talking about. So this formula has to be accompanied by an x interval that we're looking at. To use this formula properly, because it's an average, we have to be given some function and some interval. We have to have these two pieces of information. An example, directions. Find the average rate of change for this function on this interval. One thing that I caution students, if you see it written in this notation where you have square brackets, this is not a point. It's not an x, y. These are both x values that you see in here. This is the interval that I mentioned over here. We're given an expression, the x squared. It's a function, and it has to be on an interval. This is the interval. So you can label this as x sub 1, x sub 2. Notice that it's square brackets here. That means we are including these x's and all the x's in between, just like we did in this diagram here. We're looking at this little segment, which kind of looks like a straight line when you look at it out of context. And this is the average on this function over this interval, and we're kind of faking this line in here. So now we're just going to use the formula, the average rate of change formula, which again is just the slope formula that you've already learned. It just has the function notation in it. And we just want to designate that we know that it's not a constant idea, but an average idea. And we're just going to plug this in. One thing that you could do as a step-by-step process is take the time to write out f of x sub 1, right? Because we're going to need that to plug it in here. That may be helpful to some people who like organizational steps. F of x sub 1 is really going to be f of 1. If I put 1 in for x, I have to put 1 in for x over here. So that's 1 squared, which in this case is just 1. And then do the same thing for f of x sub 2. So these are essentially our y values that we're plugging into here, or the f of x sub 2 minus f of x sub 1 that we're plugging in here. So I'm going to go ahead and do that calculation right here. R is going to be equal to 4 minus 1. And then the denominator is 2 minus 1. There's nothing to calculate here. Again, these are the x values that we're going to be using. 4 minus 1 is 3. 2 minus 1 is 1. So the average rate of change for this parabola on this interval is 3. If we look at this picture in here, that's approximately a slope of 3 for a line that's passing in that area. And you can do this for any function that you want. You can do this average rate of change for, so long as you have something close to continuous in here. It's going to look a little funny if you do this thing on like a step function. Really, how would you interpret that? Because the steps aren't connected, so you don't have that same idea. So there are some restrictions to this, but I think at the Algebra 2 level, you're probably not as concerned about that, although you do see step functions in Algebra 2. As you move into pre-calculus and calculus, though, those ideas become much more important on where you can best apply the average rate of change. The slope formula you learn in Algebra 1, the average rate of change that you begin to understand in Algebra 2 and moving forward, really are foundational steps to moving into calculus. Because our definition for derivative is essentially the next step beyond this average rate of change, because we want to have an instantaneous rate of change, and that's really what the derivative in calculus gives us. Watch the video following this for a couple of practice problems that you can try, and then following that will be solutions where you can check yourself. Hopefully you find some mathematics in your part of the world that you can enjoy and share with others. Cheerful Calculations.